All right, class, in this video we want to work with congruence and corresponding parts. Now you will see that I've got two triangles, triangle A, B, and C, and I've set that across a line. Simply, you can think of this as the y-axis if you like, and triangle DEF. You'll notice that they're both 2 units from this vertical line. You will also notice my red markers. To discuss this in a previous video, the single arc means that A and D are congruent. The double arc with C and F means they are congruent. And I know B and E are congruent with the 90-degree markers. But I can also do this with tick marks. And so a single tick mark at AB and a single tick mark across DE means that the two of them are congruent. Double lines mean that EF and BC, or in this case EF and CB, are congruent. And CA and FD would also be congruent. And so I have written that all here below just so you get an idea. These triangles are not only similar, they are congruent, and it's all about being able to recognize and use the tick marks. And that helps you define corresponding parts. It helps you to mark corresponding parts. Sometimes in these videos we're able to just count up along the actual units on the graph and determine whether or not they are congruent. But perhaps in a math book or on a math quiz or test, you might not have the graph. You will just have drawings of the figures, and the only way we're going to know is either they write down a number or they show the tick marks. And tests and quizzes and math books will often just use the tick marks to show you that you have corresponding parts that are congruent. So hopefully this language below, we have seen this before. Angle D is congruent, angle A is congruent to angle D, and that's shown by the single mark. You could say that line segment AB is congruent to line segment DE because of this tick mark. It's not about defining length, it's about defining congruence. And so what I would encourage you to do is just to pause the video and just write down below this problem your corresponding parts and such from these two triangles. So hopefully you did that. We can say, let's just use our side lengths. We could say I see a single tick mark there and there. And so line segment AB is congruent to line segment FE. I could also say that AD with its 2 tick marks is going to be congruent to EH. It's going to be congruent to line segment EH. I won't write all of these down, but we could also say that DC is congruent to HG. Now notice my direction changed. It's because I went from the 90 here to the 3 arcs here at C. So that means I needed to go from H at my 90 toward the 3 arcs with G. And I just want to say that in the right way. Line segment BC is congruent to line segment FG. I could also say that let's say angle C is congruent to angle G. Or I could say that angle A is congruent to angle E. But all of those, and they all work, so it's triangle, or this would really be quadrilateral ABCD is congruent to quadrilateral EFGH. But just some simple notes on how to recognize corresponding parts. All right, so let's look at one more example here. Find the missing measure. What if the measure of angle BAC, so that's BAC, so that would start here, then there, go to A, that is this angle. That is the measure B angle C. That is 40 degrees. What is the measure of EDF? So EDF, I start with E, I go to D, and I'm going to F. And so what am I looking for? That angle right there. And so it's the middle one. I start here, and it's the middle one. That's the angle that I would be looking for. And look at that. I wrote it down wrong, didn't I? So we need to correct that. Glad I went back and checked. BAC, I put the highlighter on, BAC. I'm hopeful that you caught that. Okay? But if you didn't, maybe now you see it. It's BAC, and so I'm looking for this one. Well, now, those are going to be corresponding parts. And so in this case, I did not show any of the directions, any of the tick marks. But what if I did this? Let's go back and add those. What if I just gave you those 2 tick marks, and then I gave you these 2 tick marks? with those two sides, I know AC is going to be congruent to DF. And so with two sides, I've got an angle. I can tell that this angle is going to equal 40 degrees. That's my missing measure. Now, just for kicks, what would angle F be? What would angle F be? Let me change colors. That's not showing up too well. What would angle F equal? Well, I know that it would be 180 minus 90 plus 40. All right, this is going back to a different unit, but 90 plus 40 is 130. 180 minus 130 is 50 degrees. So this angle would then in turn be 50 degrees. I didn't ask for that initially, but that's how you would solve for that. Pause the video and try this practice problem. And so hopefully you did that, and let's see what our answer is going to be. All right, so hopefully you can see that there are two triangles here. And they are going to be, we could count up the spaces, they're going to be congruent triangles. And so that means if I'm looking for EF, then I'm also looking for BC. I can also say that that is the case. Those are going to be corresponding parts. And so let's just use Pythagorean's theorem. Remember Pythagorean's theorem, a squared plus b squared equals c squared. So we could say that is b, that is a, that is b, and the hypotenuse, the line across from the largest angle, is always the hypotenuse. And so now we substitute a squared plus b squared, that's going to be 5 squared, 6.5 squared. So let's think about this. All right, so if we do this, that's going to be a squared. 6.5 squared is 42.25. And I'm going to subtract 25 because 5 squared over here is 25, but then I have to subtract it from both sides. So that a squared then is going to be 17.25. So you remember, if I have a squared, this goes back to a previous unit, so I'm going quick. I've got to take the square root of both sides. So a is going to be approximately 4.2. All right, so the distance from C to B, it says what is EF? The distance from C to B is approximately 4.2. So guess what E to F is going to be? Approximately 4.2. All right, so we've got a Pythagorean's theorem, as I've said in class many times, never leaves. And so I wanted to pull that back up in an example of congruence and corresponding parts. All right, guys, I hope this helps. As always, please send questions if you've got them. Thanks.